Imagine our Earth as a giant orange. Now, let's slice this orange from top to bottom, creating segments that run from the North Pole to the South Pole. These imaginary lines are what we call lines of longitude. Longitude helps us pinpoint any location on Earth, east or west of a central line called the prime meridian. Longitude is measured in degrees. Each line forms a half circle, starting at the North Pole, passing through a point on the equator, and ending at the South Pole. Think of these lines as the vertical bars on a globe. Unlike latitude lines, which are parallel, lines of longitude converge at the poles. This means the distance between lines of longitude varies. The distance is greatest at the equator and decreases as you move towards the poles. Just like we need a starting point to measure distance, we need a reference line for longitude. This reference line is the prime meridian, located at 0 degrees longitude. It passes through Greenwich, England, home to the Royal Observatory. The prime meridian was established in 1884 by an international agreement. It serves as the starting point for measuring longitude east and west. Every other line of longitude is measured in degrees east or west of the prime meridian. Imagine traveling around the world, following a line of longitude. As you move eastward, you would eventually cross a line where the date changes by a full day. This line is the International Date Line, located roughly at 180 degrees longitude opposite the prime meridian. The International Date Line is not a straight line. It zigzags to avoid dividing countries and island groups. This ensures that places within the same political entity share the same calendar day. Crossing the International Date Line westward, you add a day to your calendar. Crossing it eastward, you subtract a day. This line marks the transition between 2 consecutive calendar days on Earth. Section 4. Longitude and climate. A complex relationship. While longitude itself doesn't directly influence climate, it plays a role in understanding the distribution of land masses and oceans. These factors, in turn, have a major impact on climate patterns. For example, regions located at similar latitudes can experience vastly different climates due to their longitude. Coastal areas along the same latitude may have milder temperatures than inland regions due to the moderating influence of ocean currents. The distribution of sunlight also varies with longitude. Places located east or west of each other experience sunrise and sunset at different times. This difference in solar radiation can contribute to regional variations in temperature and weather patterns. Section 5. Longitude in action. Everyday applications. Longitude might seem like an abstract concept, but it plays a crucial role in our daily lives. From navigation and timekeeping to communication and transportation, longitude is essential for modern society. GPS systems rely on longitude and latitude coordinates to pinpoint locations with incredible accuracy. Ships and aircraft use longitude and latitude for navigation, ensuring safe and efficient travel across vast distances. Time zones are also based on longitude. As Earth rotates, different longitudes experience sunlight at different times. Time zones help standardize timekeeping across the globe, facilitating communication and commerce. Section 6. Longitude. A key to understanding our world. Understanding longitude is essential for comprehending our planet's geography, climate, and human interactions. It provides a framework for locating ourselves and understanding our place in the world. From the prime meridian to the International Date Line, lines of longitude help us navigate, communicate, and appreciate the interconnectedness of our planet. As we continue to explore and understand Earth and beyond, the concept of longitude remains a fundamental tool for exploration and discovery.